Good morning, dear students. Welcome to another session of DSP Architecture and Algorithms. So, in previous session, we discussed regarding a few of the functional block diagrams related to say multiplier adder. Then we discussed regarding the barrel shifter, and then we had a discussion regarding how the CPU is present and what are the features which is present over there. For example, we had two accumulators A and B and temporary register which is used for different purposes. For example, if it is used for barrel shifter, then it stores the information pertaining to how many shifts have to be done. Then if it is used in ALU for arithmetic operation, right, when it is doing multiplication, so it is used to store the redundant extra bits which are being generated due to multiplication of the two informations. That is, say 17 by 17 bit multiplier we had discussed. So 17 by 17, the maximum size turns out to be, say for example, 2 times 17, that is 34. So if the result is 17, remaining 17 bits, if it is generated, so those 17 bits can be stored in this temporary register. So this is just a example pertaining to this. So this is how temporary register is utilized. Then along with that, we discussed other parameters like what does S stand for. S is the output which is pertaining to the shift register, the shifter, that is a barrel shifter. And then what all things are coming in with respect to ALU on how many bits it operates. So these all things we had discussed. So this is in general, these discussions were there. And apart from that, we discussed, right, for 54XX, right, we have four pairs of buses. That is program bus, a program address bus and program bus. So this is used for address and this is used for the data purpose. So similarly, we have CAB and CB, DAB and DB, EAB and EB. So these are the buses which are available. Therefore, there are four pairs. There are in total four pairs.
KTech lab, LAN connection.
KTech ನಂಗೆ ಗೊತ್ತಿಲ್ಲ ಸರ್.
ಅಲ್ಲಿ ನಿಮ್ ಕನೆಕ್ಷನ್
Sorry. So these are the four buses which are available. So these all discussions we had done. So this is again just a recap. So we had this program address generation and data address generation. So please be familiar with these terms because they'll be coming now and then. So again, we'll be not discussing those things. So we'll be just directly specifying. So this is what is happening in these aspects. So this is what will be going ahead. So this is with respect to 54XX. So now coming back to the information what we want to discuss is the different addressing modes. So how the data can be addressed. So in 54XX series, right, devices, there are around 7 addressing modes which are possible. So few of them you have we have already discussed. Around 4 we had discussed in previous module discussion. That is immediate addressing mode, direct addressing mode, then offset addressing mode. So these all we had discussed. So apart from that, we can just see that what are the other addressing modes. That is, we have first one immediate, then absolute addressing mode, accumulator addressing mode. So this is one new terminology which we come across: accumulator addressing mode, direct addressing mode, indirect addressing mode. Then we have this new thing, that is memory mapped register addressing, and lastly the stack addressing. So these are the different 7 basic addressing modes which are possible in TMS 320C54XX processor. So the name itself, in some few of the cases, for example, immediate addressing mode, what it implies, you can understand. Then say indirect addressing mode and direct addressing mode. So here in simple form, if we just specify, say direct addressing mode, the address is directly specified in the instruction. So these are the things. So we'll discuss all these things in the coming forth sessions. Today we'll discuss 1 or 2 addressing modes and then we'll wind up. So first coming down to the immediate addressing mode. So in immediate addressing mode, what happens is the instruction contains the specific value of the operand. The operand value itself is present in the instruction itself. So for example, If we come down here, we have an instruction which is termed as LD hash 20 DP. So what is happening? This hash 20 value is the operand. So this value is directly specified. So you're not pertaining to any other this thing. So this is immediate addressing mode. So the value is available immediately. The value is available immediately. So this 20 is loaded into DP register. So this is what it does. So 20 value is directly accessed. I cannot tell it as direct addressing mode. It is immediate addressing mode because you're immediately specifying the value of the operand in the instruction itself. So similarly, here also you are accomplishing the same, wherein hash FFFF is the value, and that value is stored in a register termed as RC. So this is immediate addressing mode because the value of the operand is immediately specified in the instruction. So this is how it goes around. Then apart from that, what we have is we have something called as the operand can be a short. That is, it can be 3, 5, 8, and 9 bits in length, or it can be 16 bits in length, which we term as long. So operand can be short or long. If it is short, it can be either 3, 5, 8, or 9 bits. If it is long, it will be around 16 bits. Now again, based on that, the instruction changes. So this is how it goes around. So if it is a shorthand, this thing, it occupies only one memory location. But if it is a long operand, then it will be occupying two memory locations. So in the which will be specified in the instruction. Okay. So the long operand occupies two memory locations. So this is how we go around. So if I want to say before going ahead with addition operation, say I want to clear off all the registers, say accumulator A, B, and temperature registers I want to clear off. So how I do? I can do it by directly using the immediate addressing mode. So initialization of the registers and memory locations can be done so that you will be avoiding any garbage values being utilized in your programming. So this is pertaining to immediate addressing mode. So next one which comes is absolute addressing mode. So in this one, what happens is the instruction itself will be containing the specific address of the operand. It will be containing the specific address of the operand. So along with this one, the address may be pertaining to the data memory location, which will be termed as DMAT addressing, or it can be pertaining to the program memory location, which is specified as PMAT addressing, or else it can be related to the port address. Say it may be interfacing device, and it may, when it is connected to the port, this thing, if port address is there, then it will be called as port address addressing. Then it may be a location in the data space specified by this addressing mode what he has mentioned. So here are a few examples we can see over here. So there is an instruction called as MKD 1000 hex star AR5. So what is happening is this 1000 hex is stored in this address AR5, that is address at star. You can read it as address at or address of this one. So that is AR5 in this case is telling that this is the address. So address at this point. So that address you go and store this information. Similarly, you have, so this is for DMAT addressing what is specifying. So that is KD specifies that, then MVPD, that is program addressing mode, PMAT addressing. So in this one, 1000 hex address at AR7. So what is the value in AR7? That will be utilized as the address. So this is how it goes around for the other addressing modes. So this is related to absolute addressing mode. So here you are directly specifying the specific address. So which is utilized in AR5, AR7, AR3. So directly it is being specified in this case. Okay. So then coming down to the next one, that is accumulator addressing. So here what happens is the accumulator contents itself act as the address. They'll be used as the address. This will be utilized for movement of the data between the program memory location and the data memory locations. So for example, here we have read A and write A. So these instructions will be utilizing the accumulator contents as the address. So this is what will be happening. So this is how it goes around. So what happens is I want to say read data from this location. So this is star AR2. So this is address at this point, address in AR2. Read it as address in AR2. So address in AR2, whatever value is there in that this thing. So you have to use the value at this location. Value at this location. You can read star in different forms. So one simple this thing, star you can specify as say like value at. So here if I read it, star is value at AR2, value at A. So the A is giving you the address. Here AR2 is giving you the address. So what is happening? So this is value at this location should be stored in this address information. That is, this value at this one should be stored in this information. That is address which is specified by AR2. So this is what it implies. Okay. So this is all for today. Again, I'll be starting off tomorrow with the new session. Okay.